This is a talk for the Linguistics Colloquium at the University of California, San Diego. And my name is Lisa Pearl. That's me right there. I am a professor at the University of California, Irvine, where I run the Computation of Language Laboratory. And what I want to talk to you about today is a new way to find meaningful variation in children's input across socioeconomic status. So we know, for example, that there's just lots of variation in children's input, right? From child to child, their experience is just going to be different, right? Whether it's how much data they're hearing, who's talking to them, when people are talking to them, what people are talking to them about. There's just lots of natural variation. But what about meaningful variation? Well, meaningful variation is going to impact language development. At least that's what I mean when I say meaningful variation, right? Like if you have meaningful variation from one child to the next, then the first child's language development is going to differ in some qualitative way from the next child's, right? That's meaningful variation. And something that we know is that meaningful input deficits can lead to language delays, right? So we know, for example, that input-based language delays appear across socioeconomic status, SES for short, going forward here, with lower SES children often behind their higher SES peers when it comes to different aspects of language development or the rate of language development, such as, how fast they build their vocabularies or how fast they are able to process language at any given point in time. And we also know that low SES language input can differ, doesn't always differ, but can differ from high SES input in both overall quantity of speech these children are hearing and the quality of that speech, like what's in it, right? And so there are, of course, different ways to measure quality. Quality can be measured by different aspects, focusing on different parts of the input, like, for example, diversity of the vocabulary that a child's hearing. So just a little schematic here. So maybe overall for our low SES input, if you talk about different animals, there are some, but in the high SES, there's a wider variety of animals and animal names that are talked about. Also, diversity of syntactic construction. So you might have commands and simple declaratives versus commands, declaratives, WH questions, yes, no questions, that kind of thing. And also, for example, frequency of decontextualized speech. So when you're not talking about the here and now, something in the current context is decontextualized. And so you might be talking about the past, the kitty wasn't there, say yesterday, or the future, right? And you just might hear more of that in high SES child-directed speech as opposed to lower SES child-directed speech. This is something that we know. These are different aspects of input quality, that, for example, that you can measure. And so here's the question. How can we tell if any particular input difference is meaningful? That is, it impacts language development, right? We have some difference. What does it matter? Now, here's a standard way. We notice that there's some kind of difference, right? Maybe it's the quantity of some aspect of the input, or it's just a different distribution of things in that input, but we notice there's a difference in the input. And then we measure language acquisition outcomes, right? And so then what we want to see is if that input difference that we saw correlates with any outcome differences. And if it does, then the input difference might cause the outcome difference and so be meaningful. Now remember, this is correlation, not causation, right? So it might cause, it might not, but it's at least correlated with it, so it might be meaningful, right? And that's a standard way of looking for meaningful input differences. Now, what I want to sort of introduce now is a new complementary way that uses developmental computational modeling. So again, consider our low SES versus our high SES input samples, right? And a developmental computational model is going to implement a specific learning theory, right? That's what it's doing, is making concrete a specific learning theory, right? And that theory is about how children use their input to in fact acquire the knowledge that they use to generate their output, right? It's a causal story, using your input to get that knowledge that you then use to say things or judge things or whatever outcome measure you like, right? But that's what the learning theory is doing for you, is picking out how that input translates to that acquired knowledge, right? So something that's really nice about this, something that's important, is that the learning theory implemented by the model specifies what aspect of the input matters, like it has to, because it's a causal story of how the input translates, right, is used by the child to acquire the knowledge. So we know what part, what aspect of the input matters in this case. So a developmental computational model can predict the language outcome on the basis of the input, right? Like that's what it's doing. And then if the predicted outcomes actually differ, then it's because the input difference caused that outcome difference. So therefore the input difference is predicted to in fact be meaningful, right? Now, of course, these outcome predictions need to be verified, right? But you're making a prediction that they should be there, right? And something that's kind of a bonus is because the learning theory in the model is causal, it's telling you, hey, the input should cause this difference. It can also predict if the input should cause no difference, should cause similar outcomes as well, right? In that case, any input difference is there but not meaningful, right? So that's what you're able to do with this learning theory that's embedded in this developmental computational model, is predict similar or dissimilar outcomes to determine if an input difference is or is not meaningful. So again, we have our sort of standard way of doing it and this new complementary way of looking for these meaningful input differences. And what I want to do is focus on, as you might expect, the new complementary way of doing so, right? And use it as a case study of this, syntactic island acquisition. Now, why? Well, it's because syntactic islands are higher order syntactic knowledge. And it turns out that we just don't know much about higher order syntactic knowledge, certainly not about syntactic islands per se, in terms of meaningful input differences across socioeconomic status, across SES. So that's why we're going to use that as a case study of this sort of new complementary way of detecting meaningful input differences.